This video goes over solving exponential equations. So there are some values that you should recognize or memorize. If you're in IB, you're going to have a no calculator paper and you should be familiar with these exponents. So 2 squared is 4, 2 cubed is 8, 2 to the 4 is 16, 2 to the 5 is 32, 2 to the 6 is 64, and then 2 to the 7 is 128. So the 3's, we've got 9, 3 cubed is 27, 3 to the 4 is 81, 3 to the 5 is 243, and then we've got a couple of 5's, so 25, 5 cubed is 125, and then 5 to the exponent 4 is 625. And then we've got 49, and then 7 cubed is 343. So you should be able to recognize those values because you want to be able to represent them as an exponents to help you solve some equations. So exponential equations are equations that involve unknowns as exponents. For example, this one here. They can be written in the form ax equals by. So let's see if we can solve the following equations. So on my left side, I see that I have a variable in my exponent, which means that I've got an exponential equation. What I want to do is I'm going to try and express the right side of my equation in an exponent that has the same base. If I look up at my chart, I know that I can represent 243 as 3 to the exponent 5. Now I know that since the bases are the same, my exponents have to be the same. Now I have a simple linear equation that I can solve. 2x equals 6, x equals 3. As before, when you did solving equations, I can always check my answer by putting it back into my left side of my equation and making sure it equals the right side. Let's try another example here. So on my left-hand side, I have an exponent with a base or power with a base of 5. On my right-hand side, I have something that looks like I could maybe express it as a power of 5. Because I have a fraction, I know that my exponent is going to be negative, and I can represent 1 over 125 as 5 to the minus 3. Just like in example A, now I have my two bases are the same, which means that my exponents have to be equal. And again, I've got a linear equation that I can solve. This one gives me a fraction, which is not a big deal. I can just leave my answer as a fraction. Let's check out example C. Well, this looks kind of exciting. Now I can see that I've got an exponent up here. It's got x squared, which probably means that I'm going to have to factor at some point. And I also have an 81 in front. And holy smokes, I've got a fraction on the other side. So the first thing that I really want to do is I want to get this 81 over to the other side. I can do that by dividing both sides by 81. So on my left side, that's going to leave me with 3x squared plus 5x equals 1 over, just going to leave that as 9 times 81. Now I can see on my left side that I've got an exponent with a base of 3. I want to see if I can write my exponent on the right-hand side also with a base of 3. So let's leave it as a fraction. I know I can write 9 as 3 squared. And I know I can write 81 as 3 to the 4. So that must mean that I can represent my right-hand side as 3 to the minus 6. So I did two things there. I added the exponents together because I'm multiplying two powers with the same base. And the next thing I did was bring it up to the top, changing my positive 6 exponent to a negative 6. Now my bases are the same, so my exponents must be equal. And now instead of a linear equation, now I've got a quadratic equation to solve. So my first thought would be to try factoring, which I can factor this fairly easily. I've got x plus 3 times x plus 2 equals 0, which gives me two answers, x equals minus 3 and x equals minus 2. Let's take a look at example D. So sort of like in example C, I've got a number out in front, so I want to get that by itself first. So I've got x to the 4 equals 16. Just as if I were undoing, just as if I were undoing a square root, I could take the fourth root of both sides. However, if I don't have access to a calculator, I would want to express my right-hand side in terms of an exponent that is raised to the, or a base that is raised to the 4. If I look up at my chart here, I can see that 16 is one of the powers that I should be familiar with. And I can rewrite 16 as 2 to the 4. Now this is almost the opposite of the first three that I did. My exponents are equal. That means that my bases have to be the same. Therefore, x equals 2. This is a question that should be doable without a calculator. Okay. Let's do another example here. I'm just going to rewrite it a little bit lower. I've got x to the 3rd equals 4. So I'm a little stuck here. I'm trying to figure out what number raised to the 3rd exponent or the cube root is equal to 4. Really what I want to change that left-hand side to is x to the exponent 1. Well, I can do that by cubing both sides. When I'm raising a power to an exponent, I'm going to multiply the exponents together. 1/3 times 3 is just 1, so I'm left with just x on my left-hand side. And 4 cubed is going to give me 64, which is going to give my answer of x equals 64. My last equation is where I have my x is my base, and I'm trying to solve for that base. First thing that I want to do is I'm going to divide by the number in front. If it helps you to remember, when you are solving equations, you are doing BEDMAS backwards. So when you're evaluating an expression, the brackets and the exponents come first. When you are solving an equation, the exponents and the brackets come last. So that's why we need to divide both sides by 3 before we can deal with the exponent, taking the roots and raising the powers. So the first thing that I'm going to do, I kind of have to do two things. I have to deal with this minus 3, and I have to deal with this 5. So probably the first thing that I'm going to do is I'm going to raise both sides to the exponent 1/3. As long as I raise both sides to the same exponent, they are going to be equal. If I raise both sides to the 1/3, that's going to leave me with x to the minus 1/5 on the left-hand side, and I can take the cube root of 8, which gives me 2. Now you might say, Mrs. Dittmer, we could have started by raising each side to the 5th power. Sure, we could have. I don't know what 8 to the 5 is without using a calculator. I do know what the cube root of 8 is without using a calculator, which is why I started there. So now the next thing that we need to do is we need to deal with this 5th root here. So I'm going to take the same approach that I did in E, and I'm going to raise both sides to the 5th. Okay, just like before, minus 1/5 to the exponent 5 gives me minus 1. And I also know 2 to the 5th without a calculator. That happens to be 32. I still have this minus 1 exponent here. So I'm going to change that, my left-hand side, to 1/x, because I know that's what that negative exponent means. And then on the right-hand side, I've got 32. So I haven't quite solved it. I'm almost there. Really what I'm going to do is I'm going to end up multiplying both sides by x. So I'm multiplying both sides by x here, which is going to give me 1 equals 32x, which means that x has to equal 1 over 32. That's the only possible solution to that equation that will satisfy the left-hand side and the right-hand side.